All right, so you are welcome back. So this time around we are going to look into that of function of a function, also known as composite rule, or you can also call it what chain rule. All right, in function of a function you can apply this, which is dy dx equals to dy dt times dy dt times dt ds. Alright, now in applying this is very what easy as ABCD. Okay, so this time around we are going to take some questions under it. For example, if you are asked to differentiate y equals to 4x squared plus 3x raised to the power of 3. Now, in solving this, okay, you can see this very question is quite different from the one we'll be doing before. Okay, what you will do is that you assign a variable to the brackets. Variables are A, B, C, D. I can decide to say, let t equals to 4x squared plus 3x. Then you differentiate t in respect to s using general what? Rules of differentiation. So it becomes dt, the s equals to, here becomes 8x plus 3. So from there, our y becomes, everything here is represented with what? With t. T raising to the power of what? Of 3. They cannot differentiate your y in respect to t. It becomes dy dt equals to 3t squared. Now to get dy ds is just for you to multiply these two things together. To get our dy ds, it becomes dt ds times dy dt. So from there, dt ds is taken as 8x plus 3 times dy dt is taken as 3t squared. So I can use this 3 to open up this. So it's taken as 3 times 8. It's taken as 24. 24s plus 9. Then t squared. And our t is everything here. So my final answer becomes 24x plus 9. Then my t is taken as 4x squared plus 3x raised to the power of what? Of 2. So that is my final answer. Okay, so move that to the next question. We have y equals to root 4s plus 1. Okay, in breaking down this first, it's taken as y equals to 4s plus 1 raised to the power of what? Half. Like I said, you assign a variable to the bracket. You can say let t equals to 4s plus 1. Can I differentiate t in respect to s? It becomes dt ds equals to 4. So this time around, our y is equals to, everything here is taken as t raised to power half. Can I differentiate y in respect to t? It becomes dy dt equals to, this is taken as 1 over 2 t minus 1 over 2. I believe you already know how we got that. So from there, this one is taken as 1 over 2 times 1 over t half. So which is taken as 1 all over 2t. 1 all over t half is taken as root t. So this time around, to get dy dx, our dy ds becomes dt ds times dy dt. Dt ds is sitting as 4 times dy dt is sitting as 1 all over 2 root t. We is sitting as this can cancel out this. So we'll be left with what? 2 all over root t. And our t is sitting as 4s plus 1. So our final answer becomes 2 all over root 4x plus 1. So that's our answer. So we can move that to the next question. So if we have y equals to 2x minus 3 squared. So if you're asked to differentiate that, so this is sitting as let t equals to 2x minus 3. So you differentiate y in t with respect to s, it becomes dt dx equals to 2. So this time around our y will be equals to everything here is sitting as t or t squared. So you cannot differentiate y in respect to t. Become dy dt equals to 2t. To get dy ds is to multiply the two together. So our dy ds becomes dt dx times dy dt. So our dt ds is sitting as 2 times dy dt is sitting as 2t, will give us 4t. And this time around, our t is sitting as 2s minus 3, so we cannot substitute. So which is 4, the bracket, 2s minus 3. So we can use this to open all these brackets. It becomes 8s minus 12. So that's our answer. Okay, so let's move to the next question. All right, if you share this question, this one is a combination of both function of a function. This is a function of a function, and this is a function of a function. Why everything here is known as product rule. So inside this play, we are having what? Two rules. All right. Now for this, what you do, you can say let RU equals to S cubed plus 2 raised to power 2, and V equals to S squared plus 1 raised to power what? 3. You can see that only this is function of a function and only this is function of what? Of a function. Now, what we are looking for here is du ds. But before I can get my du ds, what will I do? I'll assign a variable to the bracket. I can say let t equals to S cubed plus 2. So from here, dt ds will give us 3t squared. So this time around, my u will be equals to everything inside the bracket sitting as t raising to power 2. So it becomes du dt will give us 2t. Now to get du dx, so it's sitting as to multiply these two, dt dx, then times du dt. And dt ds is sitting at 3t squared, then times du dt is sitting as what? 2t. So this time around, sorry, this 3s squared. 3s squared. So this time around, it becomes 6s squared t. And our t is representing everything here. which is 6s squared bracket s cubed plus 2. So if you open all these brackets, sometimes if you like, don't open. If you want to open, you can open. So this one is stating as 6s squared times this, which is 6s5, then plus 12s squared. Alright, then why for this other one? We've only succeeded in getting du dx. So we are also looking for what dv ds. But before that, also assign a variable to this. You can say let's use p equals to s squared plus 1. So the p, the s will give us 2s. This time around, our v will be equal to everything here is sitting as p raised to power what? 3. So dv dp will give us 3p squared. So to get dv ds is to multiply these two, which is the p dx times dv dp, and the p ds is sitting as 2x times dv dp is sitting as what? 3p squared. So which is sitting as 6sp squared, and our p is sitting as everything here, so we give us 6s bracket s squared plus 1 squared. All right, and what we are looking for is dy dx. So in getting dy dx, don't forget is v du ds plus u dv ds. And if you go back to the question, and in the question we are told that let our u, you already know what's v in the question. In the question, our v is sitting as s squared plus 1, s squared plus 1 raised to the power of what? Of 3. Then our du dx, this du ds, will give us 6s5 plus 12s squared. Then plus our u is sitting as s cubed plus 2 raised to the power of 2. Then our dv ds is sitting as everything here, which is 6x bracket s squared plus 1 raised to the power of what? Of 2. So you can leave it like this. So this is your answer. Okay, so that's it. So this is the combined what? The combined what questions. Okay, so let's move down to the next one. If I give you y equals to 5s squared all over s squared plus 1 raised to power 2. You can see inside this place we have how many roots? 2. Okay, division there makes it what? Quotient rule, which is the general rules there. Then why only the denominator is what? Function of what? Of a function. So what you do, you can say let u equals to 5s squared and let v equals to s squared plus 1 raised to the power of 2. So from here, if you differentiate your u in respect to s, it will give us 10s. Why for this? This is function of a function. In function of a function, when you are solving, you assign a variable to the bracket. You can say let t equals to s squared plus 1. So our dt, the what? The s is equals to 2x. So this time around, v will be equal to everything here is sitting as t was squared. So dv dt is sitting as 2t. To get dv ds is sitting as dt dx times dv dt. And our dt ds is sitting as 2s times 2t. So we give us what? 4st. So we give us 4s. Our t is sitting as what? S squared plus 1. So we give us what? 4s cubed plus 4x. Now to get dy ds, to get dy ds. Don't forget, it's v du dx, then minus u dv ds, then all over v squared. So from there, our dy ds becomes, our v is sitting as everything here, s squared plus 1, then square. Then du ds is sitting as 10x, then minus our u is sitting as 5s squared. So then dv ds, which is everything here, that is 4s cubed plus 4x, then all over the denominator. Our v is what? Everything here, which is s squared plus 1, then square, then all square. So from there, we're going to have s squared plus 1 square, then 10x. I can use this to open up this. Okay, minus 5 times 4 is sitting as minus 20s5, then minus 20s cubed, then all over the denominator. And in the denominator we have what? S squared plus 1, then raised to power of what? 4. 2 times 2 will give us what? 4. So this is your final answer. All right, thank you. Let's take one more critical question. Okay, if we have roots, cube root of 5s squared plus 3 over s plus 2. All right, I told you before, cube root is sitting as 1 over 3. So first thing is to break this one down. So this is sitting as 5s squared plus 3, then all over s plus 2, then 1 over 3. You can see this very question, inside here, everything here makes it to what? Function of a function. But inside of the bracket, we have what? Quotient rule. All right, in solving this, you can say let's c equals to 5s squared plus 3 all over s plus 1. You can see now only this one is what? Is function, is quotient rule. And the quotient rule assign a variable to these two. You can say let u equals to 5s squared plus 3 and let v equals to s plus 1. So our du ds becomes 10x. Why for this? Our dv ds become what? 1. To get the t dx is sitting as v du dx, then minus u dv ds all over v squared. So our dt ds becomes, our v is sitting as s plus 1, du ds is sitting as 10x, minus u is sitting as 5s squared plus 3, the dv ds is sitting as 1 all over v. Our v is sitting as s plus 1, then square. So this time around, this is sitting as 10s times s is 10s squared. 10s times 1 is 10x. 1 times minus 5, 1 times is sitting as 5s squared, then plus what? 3. Then all over s plus 1 all square. So from there it becomes 10s squared plus 10x, then minus 5s squared minus 3. What happened? I use this minus to open up the what? The bracket. So we have s plus 1 square. So from there, our final answer there, okay, will be, which is our dt ds becomes 10s squared minus 5s squared is 5s squared, then plus 10x minus 3 all over s plus 1 raised to the power of what? 2. We've only succeeded in getting what? dt dx. So this time around, our y will be equals to everything inside this bracket is written as t raising to what? 1 over 3. So dy dt now, dy dt is written as 1 over 3, then t 1 over 3 minus 1. So don't forget, this is written as 1 over 3t. So 1 over 3 minus 1, this over 1, SCM is what? SCM is 3. Now that you have that, so this is written as 1 over 3t. 3 to 3 is 1, 1 times 1 is 1, 1 to 3, 3, so we have minus 3 over 3. So we give us 1 over 3, then t minus 2 over 3. So this time around, to get dy dx, don't forget is to multiply these two things together, which is dt ds times dy dt. And our dt ds is written as 5s squared plus 10x minus 3 all over s plus 1, then all square. Then times dy dt is written as 1 over 3 t minus 2 over 3. So this is written as 5s squared plus 10x minus 3 all over s plus 1 square. So from here, this is written as 1 over 3, then times 1 all over 3, 2 over 3. So this time, it's going to be 5s squared plus 10x minus 3 all over s plus 1 square. So we give us 1 all over 3. The here become what? Cube root of t square. And you already know what's t. T was everything inside this bracket. Okay, so from there, our final answer, which is dy ds, is going to be 5s squared plus 10s minus 3 all over s plus 1 square, all brackets. Then it becomes 1 all over 3, then cube root of our t was everything inside the bracket, which is 5s squared plus 3 all over s plus 2, all bracket raised to the power of what? 2. So this is our final answer. Thank you.